Hello there, and welcome to episode 5, I think, of Grain Sessions. Let's let's see. Let's see what episode it really is. Yes, episode 5 of Grain Sessions. Um, it's Tuesday morning on the West Coast, and I have a few agenda items to get to today. First, there's a new Datastar UI DSL. So, as we've been working on production apps at the company, uh, we've been kind of leaning into Datastar. And of course, Grain has a Datastar adapter to let, excuse me, to let the developer get minimal front end complexity and maximum return on sort of like live server side rendered UI stuff, kind of like David Nolan talked about at the last conj. And what we've been doing is just kind of having coding agents write like raw Datastar, which is fine, but there are specific seams with Grain that make sense for the adapter and for like a DSL to have more control over. Um, just to make it easier to change things in the future without breaking existing consumers, and also we've noticed that there's um, different directions that the coding agents will go in when it comes to submitting commands and queries to the back end. There's a lot of stuff with signals that can be kind of annoying to have to deal with yourself, like signal scoping and things like that. And so what we've done is I tried a couple of attempts. The first attempt, I ended up having to throw away. It was too kind of low level. And then I'm pretty happy with where the second attempt has gone, so we could talk about that. Um, I didn't record a session for this, but I added sort of user auth, sign up, sign in, all that stuff to the Grain to do list app, and just to show like what a more like sort of production oriented project might look like. Um, so we can dive into that because I have a few things to say about it. Then I'm preparing to give a conference talk. No idea if it'll get accepted, the submission will get accepted or not, but even if it doesn't get accepted for Conj, I'm going to give this talk anyway, maybe at Cyclosure or somewhere else, maybe not even like a Closure conference. So I want to have a talk prepared for Grain and its value prop. And then to continue working on this to-do list app, I think I've thought of a new direction that sounds interesting to me. So maybe if there's time at the end of this, we could start plotting out how to move in that direction. Okay, so first things first, the Datastar UI DSL docs for that are in the Grain docs folder, Datastar UI. Someone in the community has been following along with these videos, and they pointed out to me that something very convenient is because Grain is kind of delivered with all of the source code intact over GitHub, that it makes it easy for code harnesses to just go into the dependency package in the Maven cache and or the M2 cache and find documentation and stuff. So that's pretty handy. Okay, so the Grain Datastar UI DSL is essentially a system. Let me turn my background music down a little bit here. It is essentially a hiccup oriented DSL. So one of the there was a few goals. One was continue operating at a high level, so don't get too low level with it. The first attempt involved like a library of functions that the user or code agent could pick up and use. They turned out to be like too primitive, like they operated at too primitive of a level. And when I looked at the code, it just looked um, yeah, too low level. Like functions that were producing canonical data star, correct data star, but like not operating at the right level of abstraction. I really like Hiccup, and I want to remain in Hiccup. And technically, that first attempt did remain in Hiccup, but it was just like too fiddly. So one of the goals is remain in Hiccup. Another goal is don't eliminate escape hatches, and don't try to hide Datastar. So even though this DSL operates on Datastar at a higher level, it still supports like writing raw Datastar attributes, and it still supports escape hatching to JavaScript, because you're always going to need to write a little bit of JavaScript in these applications depending on what you're doing, and that's totally fine. That the point is not to eliminate the point is not to hide Datastar, and it's not to eliminate all JavaScript. This is the Datastar adapter, and therefore those things should be always available to us if needed. For instance, the DSL sometimes isn't going to support a certain case yet or whatever, and so it just makes sense to be able to drop down. And then the other goal is really to get the best out of both of what Grain and Datastar have to provide when you use them together. And so that means command and query submissions and linking to Grain-backed screens, query-backed screens and routes, all in a way that is actually integrated with the command and query registries of a Grain app at runtime, and providing essentially one pattern, like one method to submitting a command or a query. And then something else that's fallen out of this experiment is automated signal scoping. In all of the apps that I've built so far with Datastar, signals turn out to be more of a challenge to work with than I would have initially guessed. So that can take the form of I have rendered two pages that are two forms on a page that use two different commands, and they share some signal names in common. And I was having to create all these helper functions and macros and stuff for like scoped signals. So you would get, if one is for like adding a thing, you might do like with scope add, or if one was for editing a thing, you might do with scope edit. And it's just really fiddly. And so I watched that pattern develop, and then Datastar also does a thing where it will submit all of the signals to the back end, and that just creates, like on a page, like then that just kind of creates some noise. And so now the official canonical method of sending commands and queries through this DSL uses payload mode, which only sends an explicit body to the back end, which is good. And then signal scoping is owned by the DSL. And so unless there's a really special case, developers don't have to manually name things, like manually scope things. There's now sort of like automatically individuated signal names behind the scenes. And in addition to that, there's also like a kind of a lexical scoping that's now been added for signals. And And aside from that, now they've been kind of moved into like first class closure status. So there's a with signals macro that allows referring to a signal on the closure side on the back end while you're still doing the rendering, and in JavaScript expressions and data star expressions and stuff. And what that does is help with writing all of the specific data star expressions to actually reference signals, which can be not too crazy, but like I just noticed like helper functions were being generated in our projects, and also like inconsistencies with how signals actually were being written and manipulated. Because just but for the same reason that Grain exists to constrain code agent decision making, now this DSL exists to constrain decision making a bit, to keep it a bit more narrow and focused. Okay. So, and then yes, build data star attributes from data, not handwritten strings. So that's another good aspect of this. And so the form this actually ended up taking was Hiccup plus DSL specific forms converted into kind of a user interface intermediate representation to preserve the intent of what the user is trying to do. That gets turned back into ordinary Hiccup after the IR has been resolved, and it turns into Hiccup with proper like low-level data star attributes. And so the way that this idea came about was essentially saying, like, what could we do at a higher level if we take data star as a low-level compiler target, essentially? Because I believe that data star is not going to change very much. I think it's going to be a stable foundation. And so I said, what if we can think of it like a low-level language that we want to compile down into? And what that does is it gives us the ability to have developers building apps with Datastar, and then if it ever does change, they're not writing all of the manual Datastar patterns themselves, hopefully, and then the actual Datastar that ends up in the output is essentially just incidental, and can be changed because it's not the primary interface that someone is working with. So sometimes little optimizations will need to be made. Sometimes expressions will be coming out wrong, and there's an edge case or something, and we just have to update the way that the IR lowers into the final Datastar form factor, and it becomes just like a generated aspect, not something that you consider fundamental when you're working. Okay. And then yeah, I didn't want to leave this Hiccup ecosystem, and so we go to Hiccup plus DSL, um, into IR, back into Hiccup, and then that Hiccup just gets rendered into regular old HTML. And so the quick start looks like this. Like you just bring in the DSL from the adapter as the UI from the UI namespace. And then maybe you have a type ahead search, like a search box that you type into and get results back. So we're going to scope everything under here with signals. We're going to create a query signal, and it's going to initialize to an empty string. We have our ordinary Hiccup for structuring our HTML. So none of this is new. This is all just how you work with Hiccup. Now this child map here is going to have some new stuff. This is going to be like a Datastar data bind or some Datastar flag, and we're binding the value of the search of the signal to this input value just by referencing it. We got a placeholder, that's pretty ordinary. And then this is new. So on input, we have an effect we want to do. and we're going to do UI refresh. Now, refresh is the canonical way in this DSL to send a query to the grain server. And now we can just refer to it by its proper query name. And this, of course, exists in the query registry. It's created by def query, like it's not a string, it's the actual name. This query, if we were to look at its schema, would have one item in its like schema map, Q, and that's the query string. And we're just going to say, well, that should be the value of this query signal. Then we have some modifiers like debounce. This basically, we can look at it in a second, but essentially these modifiers, these turn into like these strings. Like, let's see if I can go. Let's see if we can just find an example real quick. Yes, so the modifiers, so like data on, so like on click is what we've got here, or on input, rather. Then you end up with these concatenated strings. And so modifiers exist to make that a little more data driven. And so developer or code agent isn't concatenating, building these like these strings manually, essentially. So we have that. And then this would be embedded in a larger screen context. So like a student index screen, like a list of students perhaps. This has its own outer signals, the selected student ID initializing to nil, documents open. So I think in this example, maybe there's like a documents tab or modal or something that can be opened. And then a signal for, is the page saving or not? So we have ordinary hiccup. We have a special href. This is part of the DSL. So this allows linking directly to the auto-generated routes of grain queries by official query name rather than like hard-coding routes. This, along with some other changes, allows developers to stop hard-coding routes, which makes the adapter and the DSL easier to change going forward. Of course, we have our type ahead that we're just injecting here as a function call. We have another href with some path params, it looks like. And then we have an on-click and an effect. And we can actually compose multiple effects. So we can say compose multiple effects into like one expression, basically. And we can set the signal, because this is the documents button for the student row in the index, I'm sure. So set signal, documents open to true, fire off a query for the documents content, and then in this section we can bind the visibility of the section to whether documents open is true or false signal. And then we have another button down here that is we're doing a bind/adder turns into data adder, I believe. I guess there's also data bind. Maybe it turns into data bind. And so we can see here that we're putting the disabled attribute dependent on a JavaScript expression. And so this JavaScript expression is saying if no student is selected, essentially, or the page is currently saving. And if the button is available to click, then we compose some effects. We say, hey, we're saving. This is the archive button. So we're going to say that the page is saving. And then dispatch is the canonical way in the DSL to send a command to Grain now. So we use a first class command name, and this payload is what ends up getting sent. It's the selected student's ID. If we ever want to see what this renders as, we can just call UI hiccup on the data from our screen, and then that will show what it actually lowers down to, which will just be more hiccup. It just goes to this stage. So we have what we just looked at below. There's an intermediate representation, and then if you call that hiccup function, you end up with the lower level hiccup that's right before generating the HTML. So the mental model, bind slash, attributes describe data star bindings, on slash attributes describe data star events, UI dispatch, refresh, and href are some of the most interesting parts of this. They use registry keywords and names instead of route strings and stuff. With signals, declares component local client state. There's also a way to do global signals if you need to. Sometimes you do need to. Signal handles are passed directly in bindings, expressions, and payloads, which is convenient. Let's see. So the end-to-end workflow kind of looks like you define some queries like a type ahead, student profile page, a command for archiving a student, and then like we saw above, you have a signal for your query, a signal for the selected student ID. You can bind the value of an input, and on that input, you can do your search with a debounce. You can link to the student's profile, and then you can archive the student by dispatching a command. It's possible to supply a query registry, I believe, or command registry in for tests. So like we saw with signals is it's a way to bind signals and their initialization values. There's also a couple other things you can do with them. You can set like semantic names so that you could, write tests against whether something is actually in the rendered output and stuff like that. And there's other reasons for that, but it's optional. So this is just taking a little more control over the semantic name. This thing will still have its own so I believe the way this works actually is if you give it this name, then you're creating like a stable. No, actually, because there's now I'm remembering there's a stable option. So you give it this name, you can find this thing by the name. It'll still have a generated unique name component on the generated signal name. But if you use stable, then this basically creates like page level like global signal because the name won't change between re-renders and trips to the back end and downmorphs. So it's a good way to establish signals that can be found later and referred back to in your pages if you need it. Signal handles or lexical values, you can pass them directly. We talked about that. That's pretty handy. Nested components can reuse local signal names without colliding. That's good. Because they are unique with the way that they get generated when you use with signals. So you could have two type ahead searches that work the exact same way, but they'll be, identical in an identity sense separate because they're not, their signal names are not colliding. Let's see. Yeah, stable signals are a sharp tool for page level state across independent datastar patches, such as selection state used by rows, summary panels, dialogues, and command payloads. So sometimes you want those stable page level signals. Maybe even like the saving that we saw earlier could have been a stable signal. Use stable signals only when the signal is intentionally part of the page contract. Ordinary component local state should stay scoped. Let's see, we have indexed collections. So you can create a signal that initializes to a vector, and you can actually operate on those collection signals, and you can index them in the page. So that probably looks a lot like working with tables and rows and things, and sometimes you just have a collection of values. You don't only want to have scalar signals, you want to be able to have collections that you can then also just put directly in a command now. I think commands tended to end up getting like kind of flattened before, but now the signals can be like nested closure collections and maps, vectors, lists, things like that. And you can have these signals which can be created and indexed, which is handy. So the row reads from custom amounts index and writes only that element on input or change. The whole collection signal can still be sent directly in dispatch or refresh payloads. Server re-rendering can replace the init vector when a row counts change. Indexes may be literals, signal, handles, or checked expressions. So, bindings. So bindings, input, you can bind the value. For a paragraph, you can bind the text, you can trim it, stuff like that. There's some DSL kind of primitive functions for operating, doing some basic operations on queries and or signals rather. So in a section, we could bind the show attribute, whether it's open or not. A div, we can bind a class depending on whether a signal is present. We can disable a button. We can update an inputs checked property to select it or not based on a signal value. And we can even tell certain DOM elements to ignore morphing. So we use bind value for form values, bind text for text content, bind show for visibility, bind class for class expressions, and bind attribute for attribute maps such as disabled, href, or ARIA stuff. Use bind prop for DOM properties such as checkbox checked. Use morph ignore for a browser owned DOM state that Datastar should not morph. So element level effect use element level effect for reactive Datastar effects that should run when the element is initialized or patched. So at the level of an element, like a section, we can have an effect when it gets initialized. We'd say when effect. So when this JavaScript expression evaluates to truthy, so if the page scope key is not equal to the current scope key, it's just an example, I guess. We'll do this. We'll say set signal page selection, set signal page scope key to current scope key. So we can do things when elements load up. Of course, raw non-DSL hiccup attributes pass through unchanged. That allows escape hatching directly into Datastar or just JavaScript. So we have events and modifiers on input. We can set an effect. We can go ahead and trigger a query. And like we saw earlier, we have modifiers. You can put any Datastar modifier in here. It's deliberately a little dumb, so you do have to provide the like millisecond. You have to know what you're doing, but at least you're not putting manual strings together, or the agent isn't as well. So the effect map must contain effect. It may contain modifiers. No other keywords are currently allowed. Checked event effects lower to expression safe Datastar JavaScript. Conditional helpers such as when effect and choose effect are safe to use directly in ordinary on star handlers. So on mouse down, we can have an effect, and we can do that whenever we're in draw mode and the target is the one we're concerned with. And then we can say we can escape hatch into this UI, this action DSL that lets us basically call this JavaScript function that is on the window. And this is an example that must have come from one of our document signing features in an application we have, starting a new annotation on a document. So common event attributes on click, on input, on submit, on change, on key down, on signal patch. On signal patch is cool. So on signal patch is data star signal patch hook. It uses the same checked event map but lowers to data on signal patch, not a DOM style data on star. So when the signal is patched, and we have current item ID here, we will update, we'll get the fresh data. Application code should not assemble checked event workflows with basically the essentially like IR primitives. Modifiers lower generically to data star event suffixes. There's no hard-coded modifier allow list. So basically this is just showing you can use any of these if it's in the data star guide as something that you can, let's see, data on, as one of these types of things that you could do, then it can be done from this modifiers map. Falsy modifier values are omitted. Boolean true lowers to bare suffix, and string number keyword symbol values lower to dotted suffix values. So it's referring to how these strings are built. Routes and payloads. So check navigation and server interaction use route refs. This is how we dispatch a command. This is how we dispatch a query. This is how we link to different parts of the app. UI dispatch targets a registered command keyword, so it's actually looking in the registry. UI refresh targets a registered query with its auto-generated data star route. href also targets a registered query by its auto-generated data star route. Literal route strings are rejected in these kinds of tools. Payloads are explicit. Ambient page signals are not sent. So the only thing that's sent is what is in the body, which just helps reduce noise and room for error on the back end. Also helps you understand like what's actually being sent when you're looking at this. You don't have to ask the question, is ambient page state being sent? It's not. Payloads may contain nested maps and collections. Signal handles and checked expressions are lowered recursively. So if you're sending document submit, the payload can contain this document kind of metadata map using signals all throughout. We could even send a list. We can send a set. So, and then all of this gets transformed and marshaled back up into proper Eden as per your schema for your command, because all of this is automatically checked against your schema that you've done with def schemas. And so if the schema says it should be a set, well, the Mali JSON transformer that's used in the data star adapter is going to marshal that up to a set. Because obviously JSON doesn't have a set. So maps lower to JSON objects, payload map entries whose value is nil at compile time or null and undefined at submit time for signal and expression values are omitted from outgoing object. That's important. Currently, you cannot send a nil key from here. We might add a DSL function to basically explicitly say I'm going to send nil, but right now, if any of these values are nil, it won't be sent. With the exception of vectors, lists, and sets lower to JSON arrays without filtering elements, so nil collection values will remain in a collection. So this is mostly about like say you have an optional key on your schema, but this is null on the JavaScript side, it's going to send this as null, and then that's going to conflict with what you want your interaction pattern to be because you set it to optional. So now if this is null, it just won't send, and if it's optional, then it'll pass the schema check, and if it wasn't optional, you'll get an error message because you'll get an anomaly back because it's supposed to be there. Payload maps must be static literals. Grain command query schemas remain responsible for nested validation and server-side coverage. UI dispatch reserves Grain's command route signal name for the command action endpoint. By default, this is __ Grain action. Application code should not set or read that signal directly. So then we have effects. Effects compiled to datastar action strings. In checked on star event maps, they lower as expression safe datastar JavaScript. Element level effect lowers to data effect using statement style JavaScript. So dispatch, of course, is sending commands. Refresh is sending queries. By default, refresh includes the reusable stream nonce. So that's another thing I forgot to mention earlier. The nonce handling is done for you. You used to have to be aware of that as the developer. What this does is it allows stream reuse. So like, say I'm connected as a user to the application from my browser. I have an open SSE stream. When I send a new query to the backend, by default, what this would do is close my existing one and open a new one, but instead the datastar adapter is able to say, oh, I see this nonce for this user. I'm going to keep that open. I'm just going to reuse it. I see that I have this open. I'm going to update signals and re-render the query results, but I'm going to keep the stream open. So this is handled for you. I guess you can turn it off if you want to. We can set the value of a signal. We can reset a signal to its initialized, declared initialized value. We can clear. Grain has some baked-in error signals, so we can clear those. We can call blur in the current datastar event. Action is a escape hatch essentially to post to a particular like route or something like that. Okay. And yes, you kind of go outside the bounds of everything that the DSL is doing for you when you do this, but sometimes you need that. So effects runs effects that you provided in order. So setting signals, dispatching commands or queries. When effect runs when a predicate is truthy. So there's some built-in predicates, and then sometimes you gotta do a JavaScript expression. Choose effects will choose between effects. So is the UI present? Is it present signature? If not, if so, we'll dispatch. If not, we'll set an error. On keys, runs effect by keyboard key. So you could say enter should dispatch the submit, escape should use these effects, reset the signal, and blur. So expressions compiled to datastar compatible JavaScript snippets. This is an expression, this is an expression, literal, trimming the value, number from the value of a signal, numsense, which may have snuck in from one of our projects, but we do everything in integer sense when it comes to finance stuff. Converts this signal to whole number sense. Checking if something is present, changed, yeah. Signal handles can be used directly anywhere an expression is expected. That's really nice because when you're building these JavaScript expressions, you can compose this left and right side of the JavaScript expression, but you can pass in, your usage of an expression from the DSL over a signal value by referring to it directly by symbol. Okay. Not gonna talk about the IR part, and then there's a reference. So that's the Datastar DSL. I've already upgraded Grain to-do list application to use it. So there are examples there. And so we're gonna move on from this. Can I strike through this? Perhaps not. Okay. Surely I can strike through this. Somehow. I guess not. We'll just turn it. We'll turn it green. Okay. There's a new service in town. In the Grain to-do list, I've reorganized things a little bit to help teach how to use this stuff. Now there's under the Grain to-do list namespace, there is a namespace called Foundation, which contains things that are like unitary pieces and parts, like the ability to sign and unsign a JSON web token, the ability to send an email, although in this app, there's just a logging implementation of the email protocol here. Keep things straightforward. There's some auth interceptors, which are new for user stuff, and then some UI stuff. So Foundation. If we check the README, I've explained the difference between these two things. So Foundation components are small targeted units of functionality that support the app as a whole. They hold shared infrastructure and reusable primitives such as UI, Chrome, email delivery, JSON web token helpers, and auth interceptors. That's what we see here. Then we have service components. Service components own state changes in an area of the domain. When visualized, they should look like event models and information systems. Commands introduce changes, events record what happened, read models describe useful views of state, and queries present that information back to users. And so now we have a service namespace that contains the to-do list service and the user service. User service is new. If we take a look at the schemas, we can see that we have the ability to sign up, log in, log out, reset, update the password. Email verification is built in here. Password reset. Yep. And then we have the corresponding commands. So sign up, log in, log out, set password, verify email, request password reset, request password. We have our query schemas. So sign in, these are just pages. And then verify email takes a web token. Password reset also takes a token. And then we just have a read model schema for our users. It's a map of UUID to this common user schema up here. User has an ID, email address, password, token version for keeping track of token usage, like JSON web token usage, I mean. Active, email verified, what token was used when they did their email verification, and if there's a pending, these are just for pending. So the read model is going to show them for easy comparison whenever you're actually saying, let me verify this user's email, or let me verify that they can in fact reset their password. So something to note about this is that I just pulled this from one of our other projects, like this entire user service. So Grain is really good at getting a return on investment in a compounding engineering kind of way. So because of the way that we kind of loosely design grain systems, recall uh, we don't treat the entities and structure as fundamental. We treat these groups of domain functionality as fundamental, and entities and things like that just kind of grow up within them. So I'm able to take something like this user service, bring it over, not really modify the domain of it, just some of the stuff. I had to fiddle with some of the stuff about how authentication and authorization integrates into the this particular application. And so what we have here is we've added some routes. So we've customized the Datastar routes a little bit here. For auth, we say if someone's unauthenticated, we send them back to sign in. Unauthorized, we send them back to just the root of the application. If we go look at some of the auth interceptors to show how this is actually integrated, that would be here. So the way that this particular implementation works is that there is an HTTP only auth cookie. And so we basically just kind of attach ourselves in the stream of requests, and we can tell when a command is a user logging in. And assuming that they're logging in, this is on the way out, by the way. So the command was successful, it didn't return an anomaly or anything like that. If they were logging in, then we set the auth token in their cookies, and if they were logging out, then we clear that. We have the values. This is just because we're not in a production context. You would set this to true for secure if you're in prod. And then we just have an interceptor that can, on the way in, for any request, Grain supports this Grain additional context. This gets merged into the context map that any command handler, query handler, whatever receives as its argument. But this allows a sort of, this allows you to do some glue code at the web server or adapter level. So this additional context will get merged into that. And so we can say, hey, from additional context, grab auth claims. Let's see. What was I looking at here? So from additional context, grab auth claims, grab the user ID in there, and then we're going to just associate directly into the context, into Grain additional context, raise it to the level of current user ID, so that we're not just dealing with auth claims. It'll be in there, but we'll also have just like a top level kind of user ID for the current user. And then we have this this extracts the auth cookie and sets it in that additional context. So it says, let me get the token, let me verify the token. Yes. When I have the token and a function to verify it, then I will try to unpack it basically, and that verify is going to be checking that it's basically going to be hooking up to this unsigned in the JSON Web Token foundation component. And then otherwise there will be an exception, or rather we try to do the claims, and then we conditionally associate in when claims are there. We'll put in Grain additional context, we'll put the auth claims in. So this all kind of hooks up like that, and it starts from setting these cookies and accessing them in their HTTP only. And then normalize just turns the UUID into a proper UUID for user ID and tenant ID in the auth claims. Um, there's still definitely some rough edges around authentication. Nothing too bad. But the rough edges are there because I want Grain to be extremely agnostic to how a user chooses to implement authentication in their application. Um, and so there is still a little bit of work to do there, just FYI. So that's the user service. I mean, now if we actually start this up, let me start the CSS runner, and then we'll start REPL, and I'll connect in here and start the service. Let's come down here, start the app. Okay. So now, oops, 80. So we have our sign-in page here, and of course, I don't have an account. So I'll create one. So you can see our password requirements checker going there. That's being done with a raw JavaScript expression. That's so every one of those keystrokes isn't hitting the backend. We've chosen to escape hatch into JavaScript because sometimes you're going to want that like immediacy. Create our account. So that looked like a little bit of something to improve there. That should have transitioned to a, check your email type of thing. Actually, I have it to where you don't need to verify your email address just to sign in. But if I take this magic link, or this link that I was emailed here, because remember it's a logger email, so it's going to log to the logs, the in-REPL logs. And just FYI, if you're running the in-REPL script in VS Code or something, you will probably not be able to find this because that terminal doesn't save much history. So that's why I run it in these regular terminals. So I'm going to take this link, copy it here, verify my email. And then, yeah, the email verified. So we can add a task and all sorts of stuff. And the way that this composes with the existing to-do list service is now, now all of our events have a user ID on them. And when we create them, they're tagged by user ID as well. So that's how we compose to the fact that user owns these things. And in commands, in queries we have, in our authorized metadata predicate, we can do some authorization checks. So we can say this is for, let's do one for capturing a task. So can the user capture a task? What does that say? It says, given the project that's coming in the command and the fact that the user is authenticated, and you could do better function composition on these as well, but we're embedding the authenticated check into this one, and we're saying, is there no project ID, or if there is, does the user own this project? And so project ownership is a check for authenticated, a project ID, and if we look in the read model for this user's projects, it actually exists. And so, those could probably be structured better to some extent. These are just like first pass, like AI generated predicates, but like you can do all of the function composition and checks you want in here because these authorized predicates receive the entire context, which is going to include the command. So you can do read model checks and all sorts of stuff, really. And so that's how everything's hooked up. Same way in queries. same way in queries. So authorized owns task query. So it's anywhere that you want to um, do authentication and authorization, you can do that. And then read models. Let's see if there's anything interesting in here. User ID based at this point. Yep. Okay. So yeah, that's the user service and how how it has been integrated into the project. So now we actually do have this user service and this to-do list service, and they interact. User, again, is like a special case. Like, it's one of the few cases I'm okay with just saying there's a user entity and that's what the service is called. But really, it's just a family of user related things, and then that composes with other services by the fact that there is a user ID on every event, and you tag events with user ID for indexing and control. So that is the user edition service, or the user service edition rather. Okay. I think I'm going to save these two for another day, another session. Because these are going to take a little while, and now I'm feeling a little tired, and it's been about an hour. So I hope that you have that you enjoyed the coverage of the new Datastar DSL and the coverage of showing how to add a new surface component into a project, the split between foundation and surface components, and just some of those explanations on how it all works. It's all on GitHub. Everything's up to date. So yeah, I'll catch you on the next episode. Have a good one.